My name is Emma Frank, your regular tutor. In this package, we are going to look at number and numeration, and the subtopic we are taking is number base. Behavioral objectives. At the end of this teaching, the students will be able to convert numbers from one base to another. The students will be able to perform basic arithmetic operation, multiplication, division, subtraction, and addition of numbers. The students will be able to find an unknown base to any given number. These are the objectives. Let's take the introduction. Generally, numbers are written in base 10. Example: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are numbers in base 10. These are numbers in base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how numbers are written in base 10. In real life, there are problems that require numbers to be converted from one base to another. Example: the electrical components of the computer, such as integrated circuits, resistors, wires, etc., can only indicate off and on. The electrical components, like we have, the electrical components of the computer, for instance, we have the resistors, we have the integrated circuits, even the wires, even magnetic materials in the computer. They can only indicate off and on. Okay, and so this, we say it can only indicate off and on, which corresponds to 0 and 1. respectively. 0 for off, 1 for on. And so these two numbers are numbers that are found in base 2, which correspond to 0 and 1, which are numbers in base 2. Thus, there is need to convert numbers from one base to another. Other bases such as base 8. Base 8 is called octal, and base 16 and base 16. This one we call it hexadecimal. Are significant number system. Number systems. Now, we are going to look at the numbers and their respective bases. Below are the numbers and their respective base. All right. We'll start with base 2. Base 2 number we have 0, 1. This one is base 2, 0 and 1. Then in base 3 we have 0, 1 and 2. So this is base 3. We also have 0, 1, 2, 3 will be numbers in base 4. We also have 0, 1, 2, 3 to be numbers in base 5. 0, 1, 2, 3. Okay, this is 3, 4. 0, 1, 2, 3, 4. The numbers in base 5. 0, 1, 2, 3, 4, and 5 are numbers in base 6. Now, 0, 1, 2, 3, 4, 5, 6 is numbers in base 7. Then we also have 0, 1, 2, 3, 4, 5, 6, 7 to be numbers in base 8. 0, 1, 2, 3, 4, 5, 6, 7, 8 is numbers in base 9. Then we have also numbers in base 10, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These numbers in base 10. Now, depending on the application, we need to convert numbers from one base to another. Like I've told you about the electrical components of the computer, which can only indicate off and on. So if number is given in base 10, because of the application, we have to convert it to base 2, where we will have 0 and 1 that suits the particular application. So that is why it is very essential to convert number from one base to the other. So here we are going to start the conversion, how we can convert number from numbers to base 10, given any number, how we can convert it to base 10. So this is where we'll start. Now we are looking at conversion of other bases to base 10. When converting numbers from other bases to base 10, the given base is multiplied by each number followed by adding the multiplied numbers. Thereafter, the base is raised to powers starting from 0 in increasing order. From right to left. Example. Let's take example. Suppose I wish to convert this number in base 2. I want to convert 11011 in base 2 to base 10. Now, like what we have said here, I'm going to multiply each of this number. Look at that. We say the given base is multiplied by each number. This is base 2. So I'm going to multiply each number by 2. After that, I'm going to add them, followed with addition. Then I will raise the base to powers, starting from 0, from right here to left. Now, there's something you should also notice, that in base 2, you see, these are numbers in base 2. There is no number here up to 2 or 3. In the bases that we just listed, you see that in each base that you are taking, the numbers there is less than the base. So, if number is given, say maybe base 3, the numbers that you find here must be 0, 1, or 2. No number from 3 that will be found. Okay, now let's look at this. Let's look at this. Let's look at this. How do we convert this to base 10? Based on the explanation, we can follow the following steps. Look at it. We have 11011. Now we have 11011 to base 2. And you see, I'm writing the base in words. In words, not in numbers. Because at times it's confused. If you are writing in numbers, sometimes you look as if the number is the base is among the numbers. So it is preferable that we write it in this way. Okay, so I'll now do it like this. 1 times 2 plus, 2 because of the base. 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. Notice that I'm using the base 2 to times each number. Look at that. I'm timesing each number by 2. Then we are saying that after that, raise the base, each base from 0 in increasing order from right to left. So we'll do it this way. 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. Now raise this to 0. This is 1. This is 2. See, I'm starting from right to this way. Then this is 3. And then this is 4. Look at it. 0, 1, 2, 3, 4. So after that, I'm going to simplify it to get the required results. And I will now have something of this nature. This. Okay, let me start from here. 2 raised to 4, that will give us 1 times 16 plus 2 raised to 3 is 8. So 1 times 8 plus 2 raised to 2 is 4. So 0 times 4. And then we have plus 1 times 2 plus 1 times 1. Because anything raised to 0 is 1. Right. This gives us 16 plus 8 plus 0. Because 0 times 4 is 0. Now 16 plus 8 is 24. 24 plus 2 is 26. Plus 1, then we have 27. Therefore, 11011 to base 2 is the same as writing 27 to base 10. Okay, so this is how we can convert it from base 2 to base 10. Others are done in that way. If it is base 3, or you want to convert it to base 10, use 3 to multiply each number that is given. After that, raise the number, starting from 0, in increasing order, from right to left, then simplify it. You have your required result. It's very simple to deal with. Okay, now we are looking at conversion of a given base number with fraction to base 10. Now, when converting any given base number with fraction, a given base is multiplied by each number as usual. When we are given number and we look at the given base, we use the base to multiply each number. So this is also done with number with, when number is given and the number contains fractional parts, we have to multiply them. So it is multiplied as usual. Now, the base starting from the decimal points to the right is raised to powers from -1 in decreasing order. In decreasing order. What we mean is for -1, -2, -3, that way. Of course, we know that -1 is greater than -2. -2 is greater than -3. So it means that this thing is decreasing when we start -1. And next -2, -3 in decreasing order. That is, I'm talking from the decimal points. While the base starting from the decimal points to the left is raised to powers from 0 in increasing order. So let's take an example so that we'll now see how we can convert numbers with decimal parts to base 10. Example: convert 101.011 base 2 to base 10. I'm going to convert this 101.011 in base 2. We are converting it to base 10. Now we will now pick the solution. One 101.011 base 2. Now what we are saying is that this base 2, this 2, we are going to use it to multiply each number. And then we have 1 times 2 plus 0 times 2 plus 1 times 2. These ones. Then we have the decimal points. 0 times 2 plus 1 times 2 plus 1 times 2. Now we are also saying that here, from this decimal point to the right, we are going to raise this base starting from -1, -2 in decreasing order. So here we have -1. We are going to raise the base to power such as -1. Then this one will give us -2. This side -3. If it were to be other one, it will be -4. That is from here down. While from the decimal point to the left is raised to power from 0. This one is 1 and this one is 2. That is how it is done when the number involve fractional parts. Notice that in the first one that we did, the number did not have decimal parts. It was only this way. And so what we did was to multiply each number by the given base, and then we now simplify it starting from 0. And then we take it in increasing order from right to left. But this one involves a fractional part. So the fractional part is taken from -1. I mean, you raise the base to -1, -2, and -3. So here, let's simplify it. We have 1 times 4 plus 0 times 2 plus 1 times 1. You know, anything raised to 0 is 1. Then we have decimal points. Then here, 0 times 1 over 2 plus 1 times 1 over 4. You know, -2 to this is 1 over, according to law of indices. You can also get this from your lectures on indices and logarithm. Okay, so plus 1 times 1 over 8. This is 2 raised to 3, which is 8. Okay, so we have 4 plus 0, because 0 times 2 is 0, plus 1. Then this part becomes 0. Here is 1 times this is 1 over 4 plus 1 over 8. Okay. Now this side is 4 plus 1, which is 5. Then here we take the LCM. LCM is 8. So 8 divided by 4 is 2, times here we have 2, plus 8 divided by 8 is 1, 2 plus 1. Then we have 5, 3 over 8. And this is the fractional part. But we can also find the fractional part. Let's divide 3 over 8 using long division method. 3 divided by 8, we cannot, so we put and add 0 here. 30 divided by 8 is 30. Divided by 8, we will have 4. We have 3, sorry. We have 3. 3 times 8 is 24. Then if you subtract, we have 6. 6 divided by 8 cannot, so we add 0. This divided by this can give us 7. 7 times 8 is 56. 60 minus 56 is 4. So we add 0 again. 40 divided by 8 is 5. 5 times 8 is 40. If you subtract, we have 0. Okay. So we have 0.3. This side is 0.375. Okay. So what we will have here become 5.375. You know what we are doing is 5 plus 0.375, which is 5.375 to base 10. So now we are able now to convert this. So therefore, you can write it this way, that 101.011 in base 2 is equal 5.375 in base 10. Notice that if I don't write the base 10, it is 10. In number base, if this 10 is not written, it is known that it is in base 10. So when we are converting to base 10, if I like, I can put the base 10. If I don't, it is still known that it is in base 10. Okay, so that is how it is done. It's very simple. Now we are going to look at conversion of numbers in base 10 to other bases. Now, conversion of numbers in base 10 to other bases is done by continuous division of the numbers in base 10 by the given base, until the numbers in base 10 become 0. The remainders taken from down to up or to top is the required result. Now, we are going to look at example. Convert 592 base 10 to octal. Octal is base 8. Base 8 numbers are called octal. So we want to convert this to base 8. We have said that conversion of numbers in base 10 to other bases is done by continuous division of the numbers in base 10 by the given base until the numbers in base 10 become 0. Then the remainders taken from down to up to top is the required result. So we are going to apply that by taking this continuous division. We have 592 and we are going to divide it 8. Now if we say 592 divided by 8, we'll have 74, remainder 0. We'll use this R to denote remainder 0. Now 74 divided by 8, again, what do we have? We should divide 74 by 8. We have 9, will give us 9. 9, remainder 2. Because 9 times 8 is 72. So we have remainder 2. Now we divide again. 9 divided by 8 will give us 1. Remainder 1. Okay, so 1 divided by 8 cannot divide. So we keep 1. Now look at this. We now take it in the direction of this arrow from down to top. So we have that 592 to base 10 is equal to 1120 in base 8. So this is how conversion from base 10 to other bases is done. If it were to be in base 3 or base 5, for instance, the same process also apply. Divide it by 5, which is in base 5, till the number becomes 0. Then take the remainder from down to top. All right. Next, we are going to look at conversion of decimal fraction to binary fraction. Now, when converting decimal fractions to binary fraction. The following steps are followed. Step 1. Multiply the numbers from the decimal points. From decimal point to the right. Successively by 2. Multiply successively by 2. From the decimal point to the right. Multiply successively by 2. Now step 2. Step 2. At each stage, only the right from the decimal point. Only numbers to the right on the decimal point should be multiplied. Should be multiplied. Now step 3. Step 3. Take the numbers at each stage to the left of the decimal points. From top to down. This is the required result. This is the required result. So these are the stages that we can take, the steps that we can take. At each stage, step 1 we said, multiply the numbers from the decimal points to the right successively by 2. At each stage, only the right from the decimal points, only the numbers to the right from the decimal points should be multiplied. Step 3, take the numbers at each stage to the left of the decimal points from top to down. This is the required result. Okay, so we are going to look at the example of it, so that we also see how it is done. Example. Convert 0.87510 to binary fraction. Now, from what we have said here, we can take the solution in this way. 0.875. We are going to multiply by 2 which is the binary that we are talking about. So 2 times 5 give us 10. So we put 0, carried 1. 2 times 7 is 14 plus 1. We have 15. Okay, 5, carry 1. Then 2 times 8 is 16 plus 1, 17. So this is 17. Now, reaching this stage, we are going to also multiply it as the second stage. 2 times 0, 0. 2 times 5 is 10. You carried 1. 2 times 7, 14, plus 1, we have 15. Now, if we go again this stage, we multiply by 2. 2 times 0 give us 0. 2 times 0 also give us 0. 2 times 5 is 10. So we keep the 10. Now, at this stage, we have seen that the number for the decimal part has all become 0. So, we then take the left hand side of the decimal point. Look at this decimal point, how it is arranged, the left of it. Now, notice the difference that when we were converting base 10 number to other bases, all we did was we take the remainder from down to top. But in decimal fraction, converting it to binary fraction, we take the left hand side of the decimal from top to down. So we have that 0.875 base 10 is equal 0.111, that is 0.111 base to base 2. So this is how decimal fraction is converted to binary fraction. And they are very simple to deal with. The next subtopic is conversion of non-base 10 numbers to another non-base 10. When converting non-base 10 numbers to another non-base 10 numbers. Example, conversion of base 6 numbers to base 5 numbers. First, we convert the base 6 numbers to base 10. Thereafter, we convert the base 10 numbers to base 5. So if you are converting non-base 10 number to another non-base 10, we first of all convert the number to base 10. Then from base 10, we go to the other base. For example, we look at conversion of base 6 to base 5. We'll first convert base 6 to base 10, then from base 10 to base 5. It is done also in that way to other bases, provided you are converting from non-base 10 to non-base 10. Now let's pick this example. Example, convert 1326 to base 5 numbers for that. So 132 to base 6, in base 6 to base 5 numbers. So first of all, I'm going to convert this to base 10. So this is the solution. 1326. We know that to convert this to base 10, which we have already looked at, we now say 1 times 6 plus 3 times 6 plus 2 times 6. We normally use the base to multiply each number followed with addition. Then we now raise the base to power starting from 0 from right to left in increasing order 0, 1, and 2. Okay, we can continue that this is the same as 1 times 36, and that is 6 square, plus 3 times 6 plus 2 times 1. 6 raised to 0 equal 1. So then this will give us 36 plus 18 plus 2. And so we have 36 plus 2 is 38. 38 plus 18. 38 plus 18. 6. We have 56. So this gives us 56 to base 10. Alright. We have 56 to base 10. So now, for us to get base 5, we now convert this. To base 5. And we know our normal way of converting numbers from base 10 to other bases. We use continuous division. So we now have 56 divided by 5. Now, 56 divided by 5 can give us 11. Remainder 1. Because 50 divided by 5 is 10. So 56 is 11, remainder 1. Now 5. 11 divided by 5 is 2. Remainder 1. Now 2 divided by 5 give us 0. Remainder 2. And when we are converting from base 10 to other bases, we take the results from down to top. So, therefore, 132 in base 6 is equal to 211 in base 5. So that is how we convert it from base 6 to base 5. We'll pick another example. We'll look at another example so that we'll be very, very familiar with it. Now let's pick another example. Example, convert 2232.4 to a number in base 6. Okay, so let's take the solution. We have 2232 in base 4. First, we'll convert it to base 10. And we do that, we'll have 2 times 4 plus 2 times 4 plus 3 times 4 plus 2 times 4. That is the normal way, multiplying this base by each number followed with addition. Then we raise each base from 0, starting from right to left in increasing order. So this will be 1, 2, then 3. Now, we'll now simplify it to have 2 times 4. So 4 raised to 3, is 64. 2 times 4 raised to 2 is 16, plus 3 times 4 raised to 1 is 4, plus 2 times 1. That is because 4 raised to 0 is 1. So 2 times this is 128 plus 32 plus 12 plus 2. And this will give 128 plus 32 plus 12 plus 2 will give 174 to base 10. The next subtopic is conversion of numbers with unknown base to base 10. So sometimes numbers with unknown base is given for the base to be determined. In such case, we multiply each number by the unknown base as usual. What I mean is that, when we are giving number with base and we want to convert it to base 10, we use the base to multiply each number, which we have seen. Now, if the base is unknown, the usual way will also be done by using the unknown base and multiply each number. And that is what we are trying to explain here. We just multiply each number by the unknown base as usual. Thereafter, the unknown base is raised to powers starting from 0 in increasing order. That is how we normally do it, in increasing order. So now let's take an example. Given that 104x equal 68, find x. Look at this, 104 to base x. So we have to find this x. What is the base in x? This could be easily done in this way. 104 to base x. And what we'll do is 1 times x plus 0 times x plus 4 times x. That is how we normally do it. We equal 68. to base 10. I told us that if it is not written, then we should know that this is base 10. And then we have to raise this to 0, 1, 2. And that will give us x squared, that is x squared times 1 is x squared, plus 0, that is x times 0 is 0, plus 4 equals 68. Because x raised to 0 is 1, so 4 times 1 is 4. Now what we have there becomes x squared plus 4 equals 68. So that x squared will equal 68 minus 4. So x squared equals 64. So here we are going to take the square root of both sides. Taking square root of both sides, we have x squared, so 1 over 2 equal 64 1 over 2, which is x times 2, x raised to 2 over 2, and this could be written as 64. So x is 8. Of course, square root of 64 is 8. Therefore, 104x is the same as writing 104 to base 8. You see? So we are able to determine the value of x using this process. Okay. We'll also look at another example. Now, another example. If 55 to base x plus 52 to base x equals 77. Find x. And we should also know that 77 is to base 10. So we can take the solution in this way. 55 to base x plus 52 to base x equals 77. Now, by our usual method, we can say 5 times x plus 5 times x plus the second one there, which is 52, 5 times x plus 2 times x equal 77. Now, we are going to raise this, but there is exemption in this because we see that we have plus separating 55 and 52. So we start here, raise this to 0, raise this to 1. In this way, we also raise it to 0, we raise it to 1. The numbers were not joined together. If these numbers were to be 5, 5, 5, 2, then we will raise it 0, 1, 2, 3. But it was 55 to base x separately before another 52 to base x. So that's why we raise it in that way. Okay, so by simplification, we'll have 5x because x raised to 1 is x plus 5. X raised to 0 is 1, so 5 times 1 is 5, plus 5x plus 2 equals 77. Now, 5x plus 5x give us 10x plus 7 equal 77. 10x will be equal 77 minus 7. That is, by subtracting 7 from both sides, we have this, which means 10x equals 70. So, dividing both sides by 10, we have 10x over 10 equals 70 over 10. So x equals 7. Therefore, 55 to base 7 plus 52 to base 7 will be equal 77 to base 10. So x is 7. That means if we replace 7 here and also 7 here, 55 to base 7 plus 52 to base 7 will be equal 77 to base 10. Okay. The next subtopic is addition, subtraction, multiplication, and division of number bases. The arithmetic operation of numbers is also applicable to number bases. As what we mean is arithmetic operation, that is like addition, subtraction, multiplication, division, is also applicable to number bases. Now, when carrying out such operation on number bases, we first of all convert the given numbers to base 10. Thereafter, the operation is applied. Now, apart from this particular one we are saying, this particular method, we have other methods. I don't want to use the usual addition of numbers. I want to use this particular method too. Apart from this one, there are also other methods. So we'll take example so that it will let us understand how the method is applied. Now look at the example. Add 1101 in base 2, 10111 in base 2, and 111 in base 2. We are going to add them. And so we are saying that we are going to convert each one to base 10. Now we have 1, 1. Let's start with this. 1101 in base 2. Converting it to base 10, we know we'll have 1 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. Then we raise it to powers, starting from 0, from right to left in increasing order. So if we do that, we then have 1 times 8, that is 2 raised to the power 3, plus 1 times 4, plus 0 times 2, plus 1 times 0. Okay, 1 times 1, sorry, because 2 raised to 0 equal 1. Now, we then see that this time this can give us 8, this is 4, plus 0, plus 1. This is equal 13 to base 10. 13 to base 10. We also convert this 10111 to base 2. We also convert this to base 10. We have 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2. Then we raise it to powers from 0 in increasing order. And that will give us 1 times 16 plus 0 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1. 2 raised to 0 is 1. Then this gives us 16 plus 0 plus 4 plus 2 plus 1. 16 plus 4 is 20 plus 3 is 23 to base 10. Then the next, we are going to convert 1112 to base 10. That gives us 1 times 2 plus 1 times 2 plus 1 times 2. Raise it to 0, 1, and 2. This will give us 1 times 4 plus 1 times 2 plus 1 times 1, which is 4 plus 2 plus 1. And that gives us 7 to base 10. 6, 7 to base 10. So, we are going to add this and this and this. That is, we are going to add 13 plus 23 plus 7. Now, 23 plus 7 is 30 plus 13 give us 43 to base 10. So, next, we are going to convert this to base 2. If we do that, we know our normal conversion of base 10. 43 divided by 2 give us 21, remainder 1. If we go by 2 again, we have 10. Yes, remainder 1. If we divide this again, we have 5, remainder 0. This divided by this give us 2, remainder 1. 2 divided by 2 will give us 1, remainder 0. 1 divided by 2 will give us 0, remainder 1. And when we are converting in this way, we take the result from down to top. So therefore, 1, 0, 1, 1, 1, 2 plus 1 plus 1, 0. Okay, we start 1, 1, 0. 1, 1, 0, 1. Base 2 plus 1, 0, 1, 1, 1 to base 2 plus 1, 1, 1 to base 2 equals 1, 0, 1, 0, 1, 1 base 2. So this is how we add using this method. There are another method that we can arrange the number, and we use exactly the way of addition of real numbers. Okay, so that is how it is done. So let's take another example. If 1011 in base 2 plus x in base 7 equals 25, find x, this number x. So, our usual process, we have 1011 in base 2 plus x in base 7 equal 25. So first, we'll convert this to base 10. 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. Now we raise the base to powers in increasing order 0, 1, 2, and 3. And that will give us 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. You know that 2 raised to 0 is 1. So this will give us 8 plus, now 0 times 4 is 0. Then 2 plus 1 times 1 is 1. And that will give us 11. Therefore, 10112 plus x in base 10 equal 25 could be written in this way. Could be written 11 plus x to base 7 is equal 25. Collecting like terms, we have x to base 7 will be equal 25 minus 11. I'm crossing 11 to this side. We know that it will give us negative. So x to base 7 is equal 14 to base 10. So what we will do now, we are going to convert 14 to base 7. You know 14 is in base 10. So converting it to base 7, we have 14 divided by 7 is 2. Remainder 0. Now 2 divided by 7 give us 0. Remainder 2. As usual, we take from down to up, which means x to base 7 equal 20 base 7. You see, you see that the 7, the x there become 20, because if you take it from down, you have 20 to base 7. So that means 1011 base 2 plus 20 to base 7 will be equal 25 to base 10. So this is how it is solved. Now let's look at this example. Subtract 16418 in base 9 from 18630 base 9 is subtraction of number bases. Okay, this is how we pick the solution. This question is the same as writing 18630 base 9 minus 16418 in base 9. You know, we are subtracting this from this, so we can write it in this way. So in the same way, we are going to convert this to base 10. We also convert this to base 10, and then we subtract it. Thereafter, we convert it to base 9. Now, converting this to base 10, we'll have, to base 10, we have 1 times 9 plus 8 times 9 plus 6 times 9 plus 3 times 9 plus 0 times 9. Then we are going to raise the base to powers starting from 0, and then this side become 1, 2, 3, then we have 4. So we raise each base to power starting from 0 in increasing order. We start from right to left. Thereafter, we can simplify it. 9 raised to 4 will give us 6,561 plus, this is times 1. So we have this. Okay, let me pick it one after the other. 8 times 9 raised to 3. And that gives us 729 plus 6 times 9 raised to 2, which is 81, that is 9 square, plus 3 times 9, and this is 0. No, this is 9 raised to 0, which is 1. 1 times 0 is 0. Then we are going to add them up to have 6561. plus, see, we have 6561 plus, okay, and let's time this first so that it will be easier to understand. 8 times 729 is giving us 5832. Now 81 times 6 giving us 486 plus 3 times 9 give us 27. Now the addition of all these give us 6561 plus 5832 plus 486 plus 27, going to give us 12906. So we have converted this to base 10. Next, we are going to convert this also to base 10. And that will give us 1 times 9 plus 6 times 9 plus 4 times 9 plus 1 times 9 plus 8 times 9. Then we are going to raise it to powers, as in from 0, 1, 2, 3, 4. And we have seen that 9 raised to 4, we have 1 times 6561 plus 6. 9 raised to 3 giving us 729. 4 times 81, that is 9 raised to 2 plus 1 times 9 plus 8. Why is it 8? Because 9 raised to 0 is 1 times 8 is 8. Then, by simplification, again we have 6561 plus 7. We have 729 times 6. It's giving us 4374. 81 times 4 is giving us 324 plus 9 plus 8. If we add them, we have 11,276. 11,276. Okay. Now we are going to minus 12,906 minus 11,276 from 12,906. Then we'll have 12,906 minus 11,276. That will give us 1630. So now we are going to convert 1630 to base 9. And 1630 divided by 9 will give us 181. Remainder 1. Then 181 divided by 9. 181 divided by 9 will give us 20. Remainder 1. And 20 divided by 9 will give us 2. Will give us 2. Remainder 2. 2 divided by 9 is 0. Remainder 2. So taking from down to top, we have that 186,309 30 in base 9 minus 16418 in base 9 is equal 2211 in base 9. So that is how the subtraction of number bases is done. And let's look at another example. Find P if 451 in base 6 minus P in base 7 equals 305 in base 6. So the solution will be in this form. We are going to first of all convert 451 in base 6 we convert this to base 10, also convert this to base 10. Now we start with 451. 451 base 6. To convert it to base 10, we have 4 times 6 plus 5 times 6 plus 1 times 6. We raise it to powers starting from 0, 1, and 2. We are raising the base as usual. Then we have 4 times 36, that is 6 square, plus 5 times 6 plus 1 times 1. Because anything raised to 0 is 1. Then this time this give us, that is 36 times 4. 36 times 4 give us 144 plus 5 times 6 is 30. Then 1 times 1 is 1. Plus 30, then 144 plus 30 plus 1 will give us 175. This is to base 10. Also convert 305 base 6 to base 10, and that will give us 3 times 6 plus 0 times 6 plus 5 times 6. Now, raising this to power of 0, we raise this to power of 1, we raise this to power of 2. We then have 3 times 36 plus 0 times 6 plus 5 times 1. This will give us 3. We start from 3. 3 times 36, that gives us 108, that is 3 times 36 plus 0, that is 6 times 0 plus 5. And this gives us 108 plus 5 will be 113. 113. So, now the equation 451 in base 6 minus P in base 7 equal 305 in base 6 now becomes 175. You know, when we converted this, we have 175. So this is 175 from conversion of 451 in base 6 minus P base 7 will be equal 113 base 6. 113, okay, in base 10. Sorry, in base 10. So we can write this by collecting like terms. 175 minus 113 equal P to base 7. And now, if we subtract 175 from 113, we will have that P in base 7 equal 62. Equal 62. Right. So the next thing is to convert this to base 7. And if we do that, write 62, convert it to base 7 so that we can find P. So if we do that, we'll have 8, because 8 times 7 is equal 56. So we'll have remainder 6. Remainder 6. Then 8 divided by 7 give us 1. Remainder 1. Then 1 divided by 7 is 0. Remainder 1. So it means that P is 116. We are taking it from the bottom to top. So it means that 1, we have that P now become 116. So P is 116. P equal 116. So this is how it's done. So next, we are looking at multiplication of a number base. Example, simplify 213 in base 4 times 23 in base 4. The solution, we have 213 base 4 multiplied by 23 in base 4. Now, we are going to first of all convert this to base 10, which is 213 base 4. Converting it to base 10, we have 2 times 4 plus 1 times 4 plus 3 times 4. So we rest the base from 0 in increasing order. This is 1, this is 2. So this will give us 2 times 16 plus 1 times 4 plus 3 times 1. We know that 4 raised to 0 is 1. Now, 2 times 16 is 32. We also have this. 4 times 1 to be 4. Then 3 times 1 is 3. If we add this, we'll have 39 in base 10. Next, we convert this. That is 23 to base 4. We convert it to base 10. And that will give us 2 times 4 plus 3 times 4. Then we raise the power from 0 in increasing order. So this will give us 8 plus 3. And this is 11. Now that we have converted this to base 10 and also this to base 10, we are going to multiply this and this. If we do that, 39 times 11. 39 times 11 give us 429. 429. It was 429. So now we are going to convert 429 to base 4. Because 429 is in base 10 now. So we go in base 4 to have 429 to base 4. If you divide that by 4, you have 107. 107. And this will be to remainder 1. Then 107 divided by 4 will now give us 26. You give us 26. Because I know that 26 times 4 give us 104. So we have 26. If This divided by this give you 26. And so remember 3. Remember 3. Right. Now, 26 divided by 4 also give us 26 divided by 4 will give us 6. Yeah, you give us 6, remainder 2. 6, remainder 2. Then 6 divided by 4 give us 1, remainder 2. Yes, so 1 divided by 4 give us 0, remainder 1. Now, taking from down to up, we have that 213 in verse 4 times 23 in verse 4 will be equal 1, 2, 2, 3, 1 in verse 4. So that is how multiplication is done. It's very easy. So the next subtopic is division of number base. Example, divide 2434 in verse 6 by 42 in verse 6. We have 2434 verse 6 divided by 42 in verse 6. First, we are going to convert 2434 verse 6 to verse 10. And we know that that can be done by saying 2 times 6 plus 4 times 6 plus 3 times 6 plus 4 times 6. Then we rest the power from 0 in increasing order. And this will give us 2 times 6 raised to the power 3. Of course, 6 raised to the power 3 will give us 216 plus 4 times 2 raised to the power 6 raised to the power 2 is 36 plus 3 times 6 plus 4 times 1. 6 raised to 0 is 1. Then 216 times 2 give us 432 plus 36 times 4, giving us 144 plus 18. That is 3 times 6 plus 4. So 144 plus 432 plus 18 plus 4. And that will give us 598. 598. That is for this. Then we are going to convert this, that is 42 in verse 6, to verse 10. And that will be done this way: 4 times 6 plus 2 times 6. Then we raise the basis to the power starting from 0. This will give us 4 times 6 plus 2 times 1. 4 times 6 is 24 plus 2. That gives us 26 plus 2 times 1 is 2. Therefore, we'll now divide 598 divided by 26. Divided by 26, that will give us 23. That gives us 23. So, we are going to convert this to verse 6. 23 is in verse 10. So, converting it to verse 6, 23 divided by 6 can give us 3. 3. Remainder 5. Then we have 3 divided by 6 give us 0 remainder 3. So taking from down to up, we have that 2434 by 6 divided by 42 in base 6 will be equal 35 in base 6. So this is how the division is done. Now, at this stage, we are going to stop here, and I really believe that following these principles, you can do everything very easily concerning number base. Thank you very much.